Hey, what's up? It's Andy again, and guess what? We got a problem right off the bat. Not everything is separable with ODEs, or not everything separates well. So a little example I have right here is this question right here. X prime equals 3x plus 2. So how do we separate this? Well, we would try like, okay, well, x prime equals dy, or yeah, what am I saying here? Dx dt. So dx dt equals 3x plus 2. You can subtract 3x, I guess. I mean, you get dx equals, or wait, no, dx minus 3x over dt equals 2. Well, that doesn't work. I mean, what are you going to do with that? You can't really do anything there. Let's see. You could just, divide everything by 3x plus 2, so you get dx over dt times 3x plus 2 equals 1, and then you can just multiply that over and then integrate, and that works, but like, I don't really want to deal with this. You could technically do it that way, but it's just like, I don't want to integrate that thing. It's probably really trivial. I think it's literally just logarithmic, but whatever, we're going to start off, on training wheels here. So what we're going to do, with these more complicated first order differential equations is you make the equation separable by multiplying the entire equation by an integrating factor. And we're going to call this mu, which looks like that. But you're going to notice that I put it in as, I put it in as u, because, I typed this up on my laptop and I don't know what the Greek symbol support is. But yeah, okay. So like the general ODE form is going to look like x prime plus p of t x, so some function p of t equals q of t. And what we do is we put in this integrating factor right here. We multiply it by the entire, oh, I forgot one. You put it into the entire ODE, and then you try to find a u of t that will simplify the equation. So what you do is essentially you try to get this side of the equation over here equal to u times x prime, which is by the product rule going to equal that right there. And you can see that, I've actually, that arrow should be over there. Whoops. So yeah, you try to constrain it such that you do that. And then when it becomes time to solve, because you've got that there, what you can do is you can just, okay, I've got u of x prime, and then, I've got q of t times, oh, wow, I really messed up. I'm sorry, guys. Okay. Oh, Jesus. Okay. So yeah, when it comes time to solve this thing, yeah, q of t, u of t. So what you do is you just integrate that side, and this just becomes ux equals whatever that integral is, and then you just divide by u, and you should be, you found x. That's it. So, I mean, it's not exactly separable. It could be separable, I guess, but like, it simplifies it down to something where you just need to integrate at the end. And so I've got a few examples here. So, okay. Hang on. So, okay, x prime equals 3x minus 2, the example that we had. So we're going to find, a mu here. Well, actually, first off, we should probably put this into the form that, I said before. So x prime plus p of t x equals, some q of t. So the way we do that is we just shift the 3x over there. So x prime minus 3x equals negative 2. Okay, and now it's time to do the integration factor. So mu x prime is going to be equal to mu x prime plus mu prime x, and we're going to set that equal to, we're going to multiply mu by that now. So mu x prime minus 3x mu. Okay, perfect. And we notice that, when we have it in this form here, this cancels. So that's gone. That's out of the picture. And then when we look at the remaining terms, that's got an x, that's got an x. Goodbye, x. So what we get here is u prime equals negative 3 u, or mu. Greek letters, am I right? Okay, so now we divide everything by mu. We get over here. Yeah, we're also gonna, that's, 1 second. That's d mu dt. So we could just, put the dt over there. So we get 1 over mu d mu equals, that's going to be, okay, negative 3 dt. And now we just integrate that. So we get negative 3t equals ln of mu. And now we get, we just exponentiate it. So we get e to the mu equals mu, because that's, or wait, e to the, Jesus. E to the ln of mu is just going to be equal to mu. And that's going to be e to the negative 3t. Okay, so that's good. And now we got that integrating factor, that's mu. So what we do is we just, use that right there. The, what we set mu equal to. So e to the negative 3t times x is going to be equal to, what we got over here is negative 2 times mu, so e to the negative 3t. And that's prime. So what we do naturally is we integrate. So we just get e to the negative 3t x on that side, and that's going to be negative 2 over 3, or wait a minute, just 2/3 e to the negative 3t plus a constant. And now we just divide everything by e to the negative 3t, or multiply by e to the 3t. And what we get is this. X equals 2/3 plus c e to the 3t. And yeah, as you saw from before, that's what we got as an answer before. So we did that right. Okay, let me just erase this one. Okay, perfect. Yeah, crap. Okay, that's supposed to be t squared. I love computers sometimes. But okay, let's get to work on this one. So we got, this big ugly problem right here. First off, we notice that there's a t right there. So we don't want that. We want this just to be y prime. So what we do is we divide the entire thing by t. So this is going to become y, or y prime plus 3y over t equals t minus 7 plus 8 over t. Okay, and now it's just integrating factor time. So we're going to multiply this side by mu, and we're going to multiply that by u, or by mu too, but it's just, we're going to leave that for later. Okay, so 3y mu over t, and now we're just going to, mu y prime equals to mu y prime plus mu prime y. Okay, and that was pretty easy. That cancels. Y, get rid of it. So we get 3 mu over t equals mu prime. Once again, divide by mu on both sides. You get 3 over t equals mu prime over mu. Jesus. Okay. Once again, we're just going to, that's d mu dt, so we're just going to replace that with 1 d mu. And we're going to shift over that equal sign, and we're going to do dt. We're going to integrate, and we get log of t cubed equals, oh yeah, I should probably mention, like when you're doing this step right here, constants don't really matter, so just don't worry about it. When you do the other step, constants do matter. But yeah, just an important thing to note. Okay, right there. So we know that t cubed equals mu. Okay, and now what we do, we just, use t cubed as our mu value, and multiply that by y, and we're going to multiply everything on this side of the equation by mu. So we get, let's see, that's going to be t to the 4th minus 7t cubed plus 8t squared, I believe. Okay, now we integrate. we get t cubed y equals t to the 5 over 5 minus 7t to the 4th over 4 plus 8t to the 3rd over 3 plus some constant. Now divide everything by t cubed. We get y equals t squared over 5 minus 7t over 4 plus 8 thirds plus c over t cubed. And if we look at the answer, yep, we got it right. Okay. And now we have a little bit of a tricky one for the last one, as you can see by that answer, which I'll probably blur out in post. No? Okay, well, apparently Notability doesn't want to blur it for me, so... Oh, there it goes, okay. So x prime plus 3x divided by t equals sine t over t squared. So let me just write it out. So yeah, it looks pretty difficult. So what we're going to do here, same process, just mu x prime plus 3x mu over t equals mu x prime equals mu x prime plus mu prime x. Okay, and we notice that we can cancel out that term, and that x goes away. So we get 3. We're actually, yeah, might as well just save time. 3 over t equals mu prime over mu. Separate that out, you get, it's pretty common to get 1 over mu there, and then, well, actually, no, that's like literally the entire thing you're trying to get, yeah. You basically just, it works out using natural logs most of the time. Okay, d mu, dt, integrate both sides, you get ln of mu equals ln of t cubed again, actually. Okay, so mu equals t cubed. Okay, and now we just, we do the, we sub that in, so xt cubed prime equals sine of t over t squared times t cubed. We notice that we can cancel that one out, and we're just left with sine t times t. And now we integrate that one with respect to t. And what's going to happen here is this is integration by parts. So our v here is going to be, our derivative is going to be sine. Our antiderivative of the first part is going to be negative cosine of t. We're going to set our u sub to be equal to t, and then derivative of t is just 1. So what we get here by the integration of parts formula is negative cosine of t times t minus integral of negative cosine of t dt. And what that's going to simplify down to is, oh, wait, crap, plus c. Okay, and that's just going to be negative cosine of t minus, or actually plus sine of t, because you can take that one out, plus c, and we're going to set that equal to x t cubed divided by t cubed divided by t cubed, and when you get x equals negative cosine of t over t squared plus sine of t over t cubed plus c over t cubed. And if we look at the answer, that's exactly what we have. So I hope you got what I was trying to say there. Basically, integrating factor, you try to make it into something that's actually gonna work out in your favor along the line. You're trying to simplify it down to sort of a separable equation by making a substitution. You're basically constraining the equation, so that way you can actually do that substitution. And it helps you solve first-order linear ODEs. That's all I got for you today. Thanks for watching. Bye.